Welcome to Ask and Learn.
Okay, guys, so we're going to be doing question 64 in chapter 5 from Chemistry, the Central Science. We're going to be using these reactions in black to find out what the delta H for the reaction in blue is. So when you add reactions together, you are also adding together their enthalpies. And if, let's say, you have a reaction where you have carbon on the left side and you add it to reaction with a carbon on the right side, those carbons can't cancel out. You can kind of think of this like an algebra problem. So let's see what our product is. So we have carbon monoxide on the left, hydrogen gas on the left, and methanol on the right. So in this equation, we have methanol on the right, and hydrogen on the left. So we're going to keep this reaction the way it is. However, in this reaction, we have carbon monoxide on the right as opposed to the left. So we're going to flip this equation around. So that's going to create 2CO yields 2C plus O2 gas. And since we flipped the equation, we also have to flip the delta H value. So instead of negative 221 kilojoules, we're going to have a positive 221 kilojoules. Now, we're going to put our other equation over here. It's and this is going to yield our methanol. Okay, now we're going to add these together. So we have two carbons on the left, two carbons on the right. We're going to cancel them out. Now we got an oxygen on the left, oxygen on the right. We cancel that out. So this creates a situation where we have 2CO plus 4H2 yields 2 methanol. So now we added our delta H's here, so 221 plus negative 402.4 kilojoules. So delta H for this reaction is going to be equal to negative 181.4 kilojoules. Now, people can get confused here and think that's the answer, but they're wrong. That is not the answer to this equation. Because, look, in this reaction, we're producing 2 moles of methanol, and here we're producing 1 mole of methanol. So that means that the actual delta H we're going to be using is going to be 1/2 of this. So we divide negative 181.42 over 2, and that is going to be equal to negative 90.7 kilojoules. And that is going to be the answer for the delta H that we get from this reaction.